Hello, let's take a look at the integration of inverse trigonometric functions. Of course, before we can look at integration, let's quickly look back and think of the derivative of the inverse of sine of x. So we can say the inverse of sine of x, or arc sine of x, the derivative hereof will be 1 over the root of 1 minus x squared. Of course, my x can be something different. It could be x squared, it could be x plus 1. So I've got a variety of things that could be here in x. Next, we are interested in the integral of something. So let's say we are given an integral that looks something like this. So the integral of 1 over something squared plus something squared. Then we're going to use our arctangent inverse trigonometric identity for integration. The one that we are given here, the integral of 1 over root 1 minus 9x squared dx, will look something similar to this one here. So we can identify that I have to use the arc sine inverse trigonometric integration. So what am I going to do? First of all, I will rewrite my integral. So I will say, of course, my identity states that a squared. So this one I know is 1 squared. That's straightforward and simple. Then x squared, whatever is written here in x should be squared. So 9x I can say will be 3x, because 3x squared is going to give me 9x dx. Then the integral states that this is arc sine x over a. So I can say arc sine of x, in this case 3x over a, which is 1, plus c. But we should not forget that we are reversing the chain rule. So if we reverse the chain rule, I have to find the derivative of what is inside here. The derivative of 3x is 3. So therefore, I have to say the reciprocal is 1 over 3 multiplied with arc sine 3x over 1 plus c. Of course, I can simplify this without the 1. Let's take a look at another example. Here is another example where we have to integrate using inverse trigonometric identities, and this one is a little bit more complicated. So we are given the integral of 1 over root 1 minus tan squared of x multiplied with secant squared of x dx. So the moment I see a tangent and a secant squared, I know I can use substitution. So I have to choose a suitable substitution. I know that, so let u be equal to tan of x, because I know that the derivative du dx of tan of x is going to be secant squared of x. So if I make dx the subject, then it becomes 1 over secant squared of x du. Now if I want to rewrite my integral, I can rewrite it. So I'm going to say the integral of 1 over the root of 1 minus, and of course now instead of tan I'm just going to immediately say u. So tan x is u, so tan squared of x will become u squared multiplied with, so I can still have this one here, secant squared of x. Now instead of dx, so I'm going to replace dx with whatever I have here, and this will be 1 over secant squared of x du. So secant squared divided by secant squared becomes 1. So I have now an integral in terms of du. Now I also know from my inverse trigonometric functions that arc sine, or the integral of a root something squared minus something squared, will be arc sine of x over a. So I'm going to say here, this thing is the same as arc sine of x, which in this case is u, over a, which in this case is 1, plus c. But I can also rewrite this as arc sine, and now in terms of u, so remember I used substitution, so I have to substitute back the value for u. So arc sine tan of x plus c. Just remember, so I used arc sine. If you got your final answer as this is equal to sine inverse, which is the same as arc sine, tan of x plus c. This is also acceptable, no problem.